Yes, so good morning, students. Now, today we'll be continuing our discussion on our kinematics of rigid body, and it is expected that by the end of today's session, so we all will be should be able to establish the relations of our rigid body, and I should be able to compute the motion. Now, let us start. Let me start presenting the screen. Then we'll continue with our lecture. Okay. So, I hope the screen is visible to all of you and I am audible.
Yes,
Yes,
sir.
sir.
Okay, fine. So today also, so that our outcome it is going to remain the same. Okay. So at the end of today's session, so it is expected that I'll be able to illustrate what are the different types of motions, and I'll be able to establish the kinematic relations for a rigid body by using the ICR method. So our discussion is here, so to establish the kinematics of a rigid body, it is actually restricted only to the use of the ICR method. Okay, and we are also going the kinematic relations which is there for the when I'm considering the rigid body. So at most, which is we are considering only two link mechanisms. Okay, so in in mechanical engineering, so when we have a course called the kinematics of machinery, that is coming in the fourth semester. We have a course called as kinematics of machinery, which is coming in the fourth semester. Okay, and in that course, we actually have discussing about more than two links each other. We have a 3-bar and 4-bar mechanism which is there. Okay, so we have 3-bar mechanism, we have 4-bar mechanism, and like that. So there we are actually establishing relations for a rigid body. Okay, for more than mechanisms, for more than two link mechanism. But if in engineering mechanics, our discussion it is restricted to two link mechanism and using ICR method. Okay. So now let us continue our discussion. In the in our last session, so in our previous session, we had taken two problems, right? We had taken two problems on kinematics of rigid body. So we had taken this was the first problem that we took, right? This was the first problem that we took, and in this problem, by using the ICR method, I had to compute the angular velocity of the rod, and then I have to angular velocity, and then I had to find out the velocity of the other end of the rod. This is a single link mechanism. This was a single link. Okay, so here I have only one digit, one mechanism, one link. So same ways here also, the second problem also we had considered only a single link. Okay, so now what we'll be doing is that today, now we'll be moving to after this discussion about this one more type for a single link, then we'll be proceeding to two link mechanisms. Okay, so we'll be looking at how to analyze the motion for a slider crank mechanism. So that is actually one of the important parts. We had seen the theory part in the previous session, at the start of the previous session. Okay, so we'll also be seeing that how we can do that, how we can find out the angular velocity and the velocity of the other end. Okay, and establish the kinematics of the and slider crank mechanism. Okay. So now here I have the bar AB, which is that my bar AB it is 2 meters long, and the end A is that is sliding in the horizontal floor at a velocity of 3 meters per second. The angular velocity, no, the end B, which is that it is along the slope, and the slope it is at an angle of 30 degrees. Now I have to find out the angular velocity of the rod and the velocity of the end B as it is shown. Now, in this question, what is the difference coming here? So here, the angle which is there. So the angle here, the A is at an angle of 20 degrees. Then here I am given that this angle is 30 degrees. So how much will be this for this angle? How much will be this angle then? This will be 180 minus 30, right? 150 degrees. So now in triangle, if I'm let me put this as C. So in triangle ABC, so what are the angles that I have? Video is on. Okay. So in this triangle, so what happened? In triangle ABC, what are my three angles then? Hello, am I audible?
Yes, sir.
Okay. So
Yes,
my
sir.
angles which are there, okay, so they are 20 degrees, right? 20, I have angle of 20 degrees, then my second angle is 150 degrees. What will be my third angle? What will be my third angle here?
10 degree.
It will be 10 degrees. So why do I require the 10 degrees angle? Because to find out my ICR, okay, so I have to drop the perpendicular to the velocity, right? So VA it is moving in this direction. So what will be the direction for VB? So NB will be moving in which direction?
Downwards along the 30
It
degree.
should be moving downwards and parallel to the plane, right? So this will be my direction for VB. Now, what about my now? What I have to do? I have to make my perpendiculars. I have to drop the perpendiculars from both end the point A and from the end B, right? So from end A, let me drop my perpendicular. I know this is not exactly perpendicular. So let me try. Let me try using a scale like yesterday. Okay, and then no, this is not exactly perpendicular because if, okay, one thing is I have a limitation with my tablet, okay, and secondly, the issue is that okay, so if it was exactly perpendicular, then it would have been going my line, which is my perpendicular, which is in the point of intersection I, which is that would be going outside my screen. Okay, so just for that, so let's just assume that okay, this is my. So what will be this angle then? Now I have my triangle IAB, right? Now in triangle IAB, what are my angles here? First angle, this angle will be 90 minus 20, right? So this angle will be 70 degrees. And my second angle here, this angle is 80 degrees. So what is this angle going to be remaining?
30.
This angle will be 30 degrees. So now for this for triangle IAB, now what happens? I have all the three angles. I have the and I have one side. So can I not use sine rule then? I can use sine rule and I can
So
find out. I can use sine rule and I can find out the length IA, comma IB, right? So will you do that and give me the value, give me the length IA and IB quickly? So this is 80 degrees. Now here I have 30 degrees. I can get values for IA and IB both, right?
बहुत ही आसान है दोस्तों कोई भी यूजर कोई भी यूजर अपना लाइफ
टीवी से थोड़ा दूर बैठो. Value for IA, कितना टाइम चाहिए आपको कंप्यूट करने के लिए? So I lengths IA and IB have found out. Okay. Now it is given VA, it is 3 meters per second. Implies VA equal to IA into omega AB. We can get omega AB equal to 0.7616 radians per second, and the direction it is clockwise because my VA it is towards left, so VB also is towards left. So the instantaneous center, which is at rotation omega AB, that will also be clockwise. Now in my question, what I am being asked to find out angular velocity of the rod and the velocity of the end B. Now VB equal to IB into omega AB. Right. So IB, which is we found out 3.758 into 0.7616. So VB I am getting as 2.862 meters per second. Okay. So V omega AB which and VB which is there. Okay, so VB in direction is downwards. So in my question, okay, so I was asked to find out the angular velocity of the rod and the velocity of the end B. So we have firstly we found out the angular velocity of the rod, and then we have found out the velocity at the end B. Okay. So with this we'll conclude this problem and we'll go to the next problem. Okay. So this now we'll proceed to the two link mechanism which is there. Okay. So this is, and again it's a crank slider mechanism. Okay. So or we all know as slider crank mechanism. Now here, okay, my point O which is there, my point O it is fixed. Okay, my point O it is fixed, and so at this particular instant, my crank which is there, okay, so it is given that my crank it is at an angle of 45 degrees, and my rotation which is there, that is my rotation which is there, okay, and the rotation is given as 180 RPM. Now this one, but when we are actually doing our calculations, what do? We are not using in for our calculations. We are not using in RPM, right? We are using in radians per second, right? Our calculation it is in radians per second. And so now using to convert, firstly I'll have to convert the RPM to radians per second. Okay, then I'll have to find out VA. So VA will be for VA. I'll be like we are using for the connecting crank from here, like we are using for the relation for my ICR. Okay, so I have VA equal to IA into omega AB. So like in the same manner, so here what happens? Here at this end which is that is completely fixed, right? So this is I have only motion along one direction. So VA which is there, so that will be my OA into omega OA. So with this, okay, so I'll get my velocity end. After I'm getting my velocity at the end A, so then for this connecting rod which is there, I can apply my ICR method. I'm supposed to apply the ICR method for the connecting rod of the length 1.2 meters and get the velocity at the end B. Okay. So here, even though I am not asked to find out my angular velocity, but still I will have to find out, because without getting the angular velocity of the link which is of the connecting rod, I cannot proceed to find out my DB. Okay. So what is different in this question is that here my angle which is there. Okay, so I am not given the velocity. I have to find out the velocity also. I have to find out my angle also. So that is actually making it slightly different. So we'll see that how we'll proceed. Okay. So firstly, okay, so I require firstly. So from here, okay, at the end, let us firstly complete our thing. Okay, let us locate our ICR. So the end VB which is there, since it is, and it is since my crank which is there, it is rotating in the clockwise direction. Okay, so my VA is in this direction. So perpendicular to VA which is there, so that is along the same direction of the rod itself. Okay, then from the piston, for the piston we say that is moving horizontally, right? So I will drop a vertical from there, and the intersection of both of them it is here. Now this angle which is there, okay. So now if you are considering my bigger triangle OBC, OBI, okay, I want you to observe the bigger triangle OBI. So in this, what are the angles there? For the big triangle OBI, what are the angles? What are my angles there? The first angle
Gamma.
which is there, that is 45 degrees, right? That is given. Second angle, this will be 90
Alpha
degrees,
plus.
right? That is 90 degrees. So obviously what happens? Gamma becomes equal to 45 degrees, right? 45, 90. So what is remaining? 45, right? So my gamma which is there, okay, so just the observation I can say that angle gamma which is there, that is equal to 45 degrees. Now I have to find out my angles theta and beta. So for finding out the angles theta and beta, okay, so what I can do, I have to observe that, okay, how can I get? Now the next part, okay, so what I want is it, okay, so if you are observing triangle OAB, which is triangle OAB? This triangle if you are observing, okay, so now can you apply any rule there in triangle OAB? Okay, so I know that length AB which is there, my length AB it is how much? 1.2 meters, right? Then my length OA which is there, my length OA it is given as 0.3 meters, and then angle AOB that is given as 45 degrees. So I know two lengths and I know one angle. Now can I try to apply sine rule there? Let us have a look. Okay, so applying sine rule. Okay, so I have AB upon sine 45 equal to OA upon sine alpha, right? Equal to OB upon sine of angle OAB. Now in this, okay, so because I already know gamma, I have to find either beta or theta, right? The other angle will be 180 minus the sum of the other two. So to get beta, I'll have to get alpha first. Now in this equation, so from this equation, I know AB, I know OA, and this is 45 degrees. So can I not get alpha, right? Sine alpha equal to OA divided by AB into sine 45. So will you give me the value for alpha then? Quickly. Alpha sine inverse OA. So 0.3 divided by 1.2 into sine 45. So sine 45 is 0.707. Correct? Sine 45 मतलब हम क्या बोलते हैं 1/√2 बोलते हैं ना. So quickly get me the value for alpha then. Beta equal to 90 minus alpha.
The 10.18.
Alpha या beta?
Alpha.
हाँ. 10.18 degrees. Okay. My beta it will be 90 minus alpha. Okay, so 79.82, right?
Yes, sir.
So now beta is 79.82. Okay, and I have in triangle IAB. Okay, so I have theta equal to 180 minus beta minus gamma, right? So 180 minus 79.82 minus 45 कितना आ रहा है बोलो?
55.18.
Hmm. Yes. Theta which is there, so I'm getting theta as 55.18 degrees. Okay. Now for my triangle IAB, I know one length and I know all the three angles, right? So I can now this same rule. Okay. So applying IA divided by sin theta equal to IB divided by sin beta equal to AB divided by sin gamma. करेक्ट है ना? IA नहीं, यहाँ पे A और B उल्टा हो गया ना? हाँ, IA divided by sin beta equal to IB divided by theta. IA equal to AB का लेंथ कितना है मुझे? AB का लेंथ है 1.2 मीटर. 1.2 into sin beta, right? So sin of 79.82 divided by sin gamma, so sin 45. So that means I can get IA. IB will also be 1.2 into sin 55.18 upon sin 45. And both those lengths which are there, okay, so they'll be in meters.
So
Can you
first
give
one 1.670.
1.670? Okay, IB
1.39.
now, okay, so I know the length. Now I have to get my velocity, right? Now, but for the velocity, until now हमने अभी इस वक्त हमने सिर्फ trigonometry यूज किया, अभी तक हमने VA find out नहीं किया. Okay. So for VA, what like I told you, okay, so VA equal to OA into omega OA, right? Now velocity VA equal to OA into omega OA. Now omega OA which is there, so that is my angular velocity. Now how can I convert my revolutions per minute to angular velocity? यूनिट आरपीएम को मैं रेडियंस पर सेकंड कैसे कन्वर्ट करूंगा? आपने स्कूल में देखा है सर, ये
So
टर्म
2
आपने
pi
कभी देखा है?
upon
2 पाई n डिवाइडेड बाय 60.
60.
क्योंकि why is that so? एक कंप्लीट सर्कल जो है, ओके, कंप्लीट सर्कल उसका एंगल कितना है? टोटल है मेरा कितना रहता है एंगल कंप्लीट सर्कल का? कंप्लीट सर्कल जो है
360.
उसका एंगल कितना रहता है मेरा? 360 डिग्री रहता है ना. एंड व्हेन आई एम एक्चुअली टॉकिंग अबाउट रेडियंस, देन 360 degrees which is that is equal to 2 pi. ठीक है, 1 a pi which is that pi radians equal to 180 degrees. ये कन्वर्शन याद रखना, आपको आगे भी कहीं पे काम आ सकता है. ठीक है, to convert my revolutions per minute to radians per second, okay, so firstly I have to convert it into revolutions per second. So to convert it into revolutions per second, so I am dividing it by 60 minutes to 6 seconds में convert करने 60 में divide किया. Then to convert my revolutions to radian, I am multiplying it by 2 pi. So then it becomes converted to radian. So what I am doing here, I know my length OA which is there. My length OA that is given as 0.3, right? So 0.3 into 2 pi into 180 divided by 60. So can you quickly tell me what is the value of VA? VA कितना है?
5.654.
बाकी सब सोए हुए हैं क्या? वो हर शेख की जो आंसर करते हैं, बाकी सब नींद से उठे नहीं है, तो सबके मुंह में पानी मारना पड़ेगा। हाँ, so VA which is not okay, so we are obtaining like this. So omega AB which is that will be VA upon IA. VB equal to IB into omega AB. Okay, so instead of omega AB, so let me write this equation. Let me substitute this. IB into VA upon IA. So IB कितना था? 1.393 into VA 5.6547 divided by 1.670. My VB which is there, okay. So I'm getting my VB as 2.43 meters per second. And my VB which is there, okay. So here what will be my, my direction of VB which is, sorry?
Sir, answer of VA 3.386. WAB we have to find out, na, in the first one. I mean the above one. There 3.386.
No, what I did, okay, so from omega AB which is there, that is not W, that is omega. Okay, so omega, omega which is there, okay. No, actually आप देखोगे ना अगर इसमें, तो आप नेट में थोड़ा देखोगे तो ओमेगा को ऐसे नहीं लिखते, डब्ल्यू के स्मॉल डब्ल्यू के जैसे नहीं लिखते, ओमेगा को थोड़ा ऐसे लिखते हैं। बट क्या है, हम लोग को लिखते लिखते वो जल्दी से आता नहीं है। ठीक है, तो इसके लिए हम क्या करते हैं, वो डब्ल्यू के जैसे हो जाता है, स्मॉल डब्ल्यू के जैसे हो जाता है। Okay, that is not actually the actual representation which is there. Okay, so for that you can look at the net. But this is not W. Okay, so this is omega. Okay. So what I did here was, okay, omega AB equal to VA upon IA जो है उसको मैंने directly यहाँ पे डाल दिया. Okay, because I can say that VA equal to, okay, or VA upon IA equal to VB upon IB. Because both of them they are equal to omega AB, right? Both of them are equal to omega AB for that particular triangle, for this particular condition. ठीक है, अभी मेरे को अगर नोटेशन चेंज हो रहा तो वो भी चेंज हो जाएगा वहां पे, बट इन द ट्रायंगल आई कैन से इट लाइक दिस. So saying that, okay, so I have VB, okay, I am obtaining it as 2.43 meters per second, which is my final objective, right? So I am supposed to find out the velocity of the piston. So my velocity of the piston, which is that is denoted by VB, and I am obtaining it as 2.43 meters per second. Okay. If you have anybody, you have any questions, you can ask me. Now, because this was for a two-link mechanism, this is our first problem. If you have a question, you can ask. Okay, so we'll go to the next question. Here, the crank of a slider crank. Now, this is another and different slider crank mechanism. Okay, so this is rotating at a constant speed of 30 rpm, and it is given that it is rotating clockwise. I am supposed to determine the velocity of the piston A at the given instant. Here, the lengths are also given. My length AB it is 400 mm, and my length BC that is 100 mm. Okay. Here when I'm doing, okay, so here what happens, firstly I'm not given the direction, I don't know my direction of the velocity also. Okay, so for firstly what I have to do, I have to write what is my direction of my velocity VB, which is acting towards which direction. Since here my point C which is there, crank which is there, so the center of the crank that is fixed, so point C it is fixed. What happens, my BC which is there, okay, so this for the link BC, my instantaneous center is there, that is always lie at C only, because there is only rotational motion, right? Then What about my velocity? Velocity, it will be perpendicular, it will be tangential to the circle, or it will be perpendicular to my link, right? So at that instant, so here, since my link it is at 60 degrees, it will be exactly perpendicular to my link. So this will be my VB. And since VB is going in this direction, so automatically what happens, my VA which is there, okay. So VA, what will be my direction of VA? It will be towards, moving towards left, or it will be moving towards right. What do you think? Hmm? VA, it will be moving towards right or towards left?
Left.
मतलब लिंक ए भी जो आपको मतलब रबर बैंड है टच करने के लिए, आपको VB इस तरफ मूव कर रहा है, तो आपको ये लेफ्ट की तरफ कैसे मूव करेगा? This is a rigid link, right? We are studying a rigid kinematics of rigid body, right? rigid body का डिफिनेशन क्या होता है? नहीं ठीक है, कोई बात नहीं, आपने आपको लेफ्ट सोचा वो ठीक है, कोई बात नहीं, लेकिन आप रीजन समझ के लो कि क्यों लेफ्ट नहीं है. आपका रिजिड बॉडी है, द लिंक ए बी दैट्स अ रिजिड बॉडी, राइट? तो व्हाट डू यू मीन बाय रिजिड बॉडी? उसका
So fixed
डायमेंशन, उसका
composition
प्रॉपर्टीज वो
होता है.
चेंज, उसका
हाँ.
लेंथ हो गया, उसका ये वेट हो गया, वो चेंज नहीं होगा ना विद रिस्पेक्ट टू द फोर्स एक्टिंग और विद रिस्पेक्ट टू टाइम.
Yes.
उसको मैं
Four
रिजिड बॉडी बोलूंगा ना.
four second.
So what happens now? Since the end B of the link it is moving towards right, automatically the link end A which is that will also be moving towards right only, right? So VA का direction क्या रहेगा आपको? Towards right रहेगा ना? Then now I have to make the perpendicular. अभी मुझे ICR मेरे को locate करना है. तो VA का सिंपल है, मुझे क्या करना है, मुझे खाली एक perpendicular ड्रॉप करना है. तो perpendicular मैं ऊपर भी कर सकता हूँ, नीचे भी कर सकता हूँ. So what happens to link BC? At the end B मुझे velocity को perpendicular बनाना है. कौन से डायरेक्शन में बनाऊंगा? अपवर्ड्स बनाऊंगा या डाउनवर्ड्स बनाऊंगा? It my VB which is there, VB it is perpendicular to link BC, right? तो मुझे VB
Downward.
को VB को अगर मुझे perpendicular बनाना है, तो that will be along the link BC itself, right?
Yes, sir.
My velocity, my angular velocity vector which is there, okay, so the line of action that will be along the link BC itself, right? So along the link BC मैंने अगर बनाया, so which I will have to make towards this direction, I will have to make downwards, right? तो अभी यहाँ पे देखो मेरे को स्क्रीन का लिमिटेशन है, वो दोनों मुझे ज्वाइन नहीं, मुझे वो ये नहीं होगा, कनेक्ट नहीं होगा. So now my VA which is there, so my VA it is acting in this direction, my VB was acting in this direction, and I am able to locate my ICR here. Now in this triangle here, okay, so I have some more. मुझे यहाँ पे केस में, here I was given that this at this instant this angle is 60 degrees, so I have to get for this angle, है ना? ये एंगल मुझे चाहिए, ये एंगल मैं 120 डिग्री में डायरेक्टली लिख सकता हूँ, but this angle I'll be finding out using the sine rule for triangle ABC. Okay, so apply sine rule to triangle ABC and get angle BAC. I have to get either angle BAC or angle ABC, कोई तो भी, okay. Whichever angle, once I'm getting one angle, the other angle is also automatically obtained. In that procedure, okay, so I'm obtaining angle BAC as 12.5 degrees. You can check that out. Okay. Now, in my triangle scissor, so ये total angle मेरा कितना हो जाएगा? Angle IAB कितना होगा ये? This will be 90 plus 12.5, right? Correct?
Yes, sir.
90 plus 12.5, so that will be 102.5. Then this angle, okay, so if this angle is 12.5 degrees, so automatically in triangle ABC, the second angle with the angle ABC which is there, the angle ABC that is 47.5 degrees. And when my angle ABC is 47.5 degrees, okay, so then my third angle which is there, okay, so this angle it will be 180 minus 102.5 minus 47.5. it will be coming as 30 degrees. That's why this is 30 degrees here. Hint. Link B is moving towards right, V8 is moving towards right. So, automatically, my instantaneous center which is there, the rotation will be always towards right. Now, since the position which is there, my instantaneous center, it is below my links, it is the position, it is below the links. So, here it is coming as clockwise. If my position was above the links which was there, then what would happen? It would have been anti-clockwise. Okay. So, try understand that difference there. Now, ये क्वेश्चन में मैं बाकी का मैं स्टेप्स जो है ये एंगल निकालने का स्टेप्स नहीं लिखा क्योंकि दैट इज सिमिलर टू द प्रीवियस क्वेश्चन. Okay, then I have to find out my angular velocity which is there. Okay, so in this question I am given that it is the length of the link BC which is there. Okay, so let us do that first. Let us find out VB first. Okay, so to find VB, so VB equal to BC into omega BC. Length BC is 0.1 meters into omega BC is 2 pi into 30 divided by 60. By this, okay, so you can get VB directly. VB which is a 0.3141 meters per second. Now, in triangle IAB, AB equal to 0.4 meters, then angle IAB equal to 102.5 degrees, angle IBA equal to 47.5 degrees, angle AIB equal to 30 degrees. And then applying sine rule, IA equal to angle IBA is 45 degrees. Okay, so sine 47.5 divided by angle AIB divided by sine 30 multiplied by AB is 0.4. Then same ways IB equal to sine 102.5 into 0.4 upon sine 30. आई एन आई बी का वैल्यू बोलूं 0.5898 मीटर. ये वैल्यू आया क्या 0.5898
Yes, sir.
0.7810.
Yes, sir.
Now VB equal to IB into omega AB. और हम लोग ये काम करते हैं VB इक्वल ओमेगा AB इक्वल टू VA अपॉन IA इक्वल टू VB अपॉन IB, राइट. So implies from this VA equal to IA divided by IB into VB. ठीक है, हमने कुछ अलग से रिलेशन कुछ भी नहीं लिखा है. हमेशा हम क्या करते हैं VB इक्वल टू IB into ओमेगा AB करते हैं then we get omega AB, then we substitute that in VA equal to IA into omega AB. ये करते हैं. अब यहाँ पे हमने क्या किया, ओमेगा AB इक्वल टू VA अपन IA इक्वल टू VB अपन IB ऐसे किया, एंड वी रोट द एक्सप्रेशन डायरेक्टली. बस उतना ही डिफरेंस है, कुछ और नहीं है. ठीक. सो नाउ टू गेट VA, IA इज 0.5898 upon 0.74, sorry 7810 ना. 0.7810 into 0.3141 implies I can say that my velocity of the piston which is there. Okay, the velocity of the piston, okay, so denoted by VA. Two 37 meters per second. तो अगर मुझे करना है तो ठीक है, 0.24 meters per second लिखी. Okay, so students, if you have any questions, okay, about the kinematics of rigid body, then you can ask it. So in this module, okay, so firstly we started with, okay, those different okay, examples, okay, so where we have combined motion of translation and rotation, which is there, okay, where we had combined motion, then we saw a few animations, then we define, okay, what is my general plane motion, then how to find out for my how to change my general plane motion into a pure rotational motion by the ICR method. Okay, then so for the ICR method, now I'll be requiring my angular velocity. Then after the angular velocity, so we did this firstly for a few of the examples. Okay, so we saw that, okay, as my object it is changing. Okay, so as my object it is changing, so then how my instantaneous center which is there, how my instantaneous center is changing, right? We saw that with the position which is there. Okay, so as the terms where it is called as my instantaneous, right? So that at each instant, at each second or each microsecond is there. Okay, so the position it is continuously changing. Then so for some examples which is there. Okay, so then we saw about pure combined motion, then we saw for pure linear motion, then for pure rotational motion which is there. Then about rolling without slipping. Then we saw for a slider crank mechanism in the previous session, and we solved two numericals in the previous session. Okay, about both of them they were for a single link mechanism which is there. Then today we have taken, firstly we took a simple case of a single mechanism as a revision. Okay, and then we have taken two cases for a slider crank mechanism. Okay, so if we have a slider crank mechanism, then how I can compute it. So this was for a crank connecting rod system, and here also it is this is slider crank mechanism. Okay, so nobody has any questions here.
So please take to the
Which question?
pure linear motion slide.
Pure linear motion slide. Okay, fine. Just a minute. Yeah.
Okay, sir.
In the case of pure linear motion, what happens? My instantaneous center, which is there, okay. So my instantaneous center, it will be lying along that same link only, right? Because I do not have my or my perpendicular to both the velocities which is there. So where is it lying? It is lying on that. They'll be lying on the same line, correct?
Yes, sir.
Now, even if my okay at the end or at this position also okay. So then in this position, what happens if my link is becoming like this also? Okay, so then also my velocity vector is in this direction only, right? In this case also what happens for both the cases, my velocity vector is acting along that same direction. Sorry, this not this should have been in this direction. Okay. Now there I have a few actually I have a interesting problem for you. You can try it out. Okay. So you can take a screenshot of this and you can try to solve this. Okay. Wherein, okay, so this is my slider crank mechanism which is there. Okay, so this is actually a piston connecting rod system inside the engine, and here I am given what is my length. I am given both the length. I am given the length of my crank and my connecting rod, both the lengths each other. Okay, so it is rotating with a constant angular velocity of 1000 rpm which is there. 1000 rpm means how much is it in radians per second? It is 104.72 radians per second. That is my angular velocity which is there. Now I am supposed to determine the velocity of the piston T and the angular velocity of the connecting rod for three given cases. First case is when theta is 0 degrees. Now when theta is 0 degrees, at that position what happens? My piston and my crank, slider crank which is there, what is my mechanism? In that case, okay, when theta is equal to 0 degrees, then what happens? Just for the sake of, for the discussion which is there, okay. Now let me take my first case. Okay. When theta equal to 0 degrees. So when theta becomes equal to 0, what happens? My
So
link which is
piston will
there.
move upward.
Yes, that is correct. Okay, I want you to observe this. Okay, it is my crank which is there, it is rotating with a constant velocity of 1000 rpm clockwise. So I have to let me mark that. This is my omega AB, right? So omega AB is clockwise. So when theta equal to 0 degrees, which is there, okay. So this will be my link A. Then this will be my link B, and from here it will be my link BD, right?
Yes, sir.
When theta is 0 degrees, it will be like this. Then the next case, which is there, when theta is 60 degrees, so that will be similar to this. Next case is when theta is 3, which is there, when theta is 90 degrees. When theta equal to 90 degrees, then what happens? When theta becomes equal to 90, in that case, what will be the position then? My link A, which is there, that will be like this, right? A here, B here. And then my link BD, it will be like this, right?
Yes, sir.
This will become a right angle triangle. That actually makes this problem interesting to see that, okay, the different, all the three cases which are there, okay, so you can have a comparison of all the three cases. Like what will be the angular velocity of the piston, okay, and the connecting rod. So in all the cases here, I have to find out omega BD and I have to find out VD. At the end हमको निकालना उतना ही है. Again, for three different cases, I have to find out. Okay, so there actually comes the understanding of I have to understand about my pure linear motion case also. Okay, even though it is rotation, but in this particular instance, what happened? Both my both my they are along the same line, right? मेरे को I किधर रहेगा ये case में? In this particular case, where will I be?
Sir,
This
throughout
is
the
rotating
line.
in this direction. इसका भी मेरा motion जो है, इसका भी मेरा
A पे
motion
fixed
कौन सा
रहेगा,
direction
sir.
में है? Towards here रहेगा ना? So my ICR will be there. Okay, so shouldn't it be at I here itself? Shouldn't it
Yes,
be
sir.
at A? Because A is fixed point, right?
Yes, sir.
So the ICR of the point of BD which is there. Okay, so that will be lying along this line itself. The ICR of BD which is that will be lying on this line itself. जो हमने pure linear motion का case देखा था. In this case, it will be my normal this thing. Then another case is case 4 if I am saying okay. So when theta equal to 180 degrees. So वो केस में मुझे क्या होगा theta equal to 180 degrees में just imagine, try to imagine what will happen. My link AB is here, my link AB is here, AB is here. Then sorry, AB नहीं, यहाँ पे BA आना चाहिए. A point fix है ना भैया. This will be A will be here itself, B will be coming here. इस 180 मतलब एकदम down ये the link point B it will be here. Right? So then from here I will be starting for D. Then my position D will be coming like this. So when theta equal to 0, like we told yesterday, it is theta equal to 0 degrees means that will be my top dead center. Remember the term yesterday? And when theta equal to 180 degrees, that becomes my bottom dead center. Okay?
So both the case answer will be
It will be
nearly
different.
same
It will be
or
different.
different.
Yeah, it will be nearly similar. Okay, but you can the angular. It is about the angular velocity of the connecting rod. Okay, so what actually makes this question interesting is that okay, so for each of the three cases, it is where my ICR position that is different, right? For each of these cases, my ICR's position is different. Then my angular velocity that is depending on my length of the link, right? That is also be kind of different. Okay, so that is what makes actually this question interesting. Okay, so in the next session, before we are starting our next session, okay, so we have a discussion. We'll have a 5 minutes discussion about this problem. Okay, so in the meantime, you can try to solve it.
Sir,
Huh.
move to the another slide. Like forward, yeah. Here ICR of first and second case when theta equals to 0 and theta equals to 90. Uh, both the ICR lies, I mean, not 90, I would say 180 and 0 for both of them. The ICR is at same point only, no? It is like
It will
throughout
along the
the
say it
straight
will be
line.
along the same line, not along the same point. I cannot say that. It will be on the same point. That is what actually try to solve it. सॉल्व करो कुछ
How
कुछ
the same point?
करो. जब तक देखो अब जब तक आप पेपर पेन लेके आप करोगे नहीं, बैठ के आप ड्रॉ करोगे नहीं, वो अंडरस्टैंडिंग आएगा नहीं. सो व्हेन यू आर ट्राइंग टू डू दैट, देन योर माइंड विल दैट स्टार्ट्स वर्किंग. ओके.
Okay, sir.
Yeah, so then you can go back to the theory part, point which is there. Okay, so you can look back at the theory that we discussed, and that will help you out. Okay,
Yes,
so
sir.
with that, okay, so we'll conclude for today, and we'll also conclude this module. Okay, so now let me have your attendance quickly in the chat box. If you're given the attendance, then you can leave the meeting. Okay.